Accion Labs Innovation Summit 2019.
Good morning, everyone. At this time, we are very excited to talk front-end applications. In particular, blazing fast front-end applications. How's that for a pretty interesting title? Server-side rendering to speed up front-end apps, and Flutter arriving with a bang. To speak on this important topic, we have two esteemed colleagues. Please join me, gentlemen. Vaibhav Satam, a very passionate JavaScript developer who delivers high-performance applications for us. When asked what he likes to do in his free time, he said study algorithms. How about that? When I was asked, it was tennis, but okay. How about that? That's why these are the smart guys up here. Also joining him is Chinmay Dalvi, a team lead for us, who has a lot of experience in web development and loves exploring website application trends and developing front-end applications that are consistent across all the major browsers and devices that we see in the world today, and making sure that they're in accordance with the best standards for all projects. And he is currently also working with the Accion Breeze platform for us. So please give a warm welcome to these fine gentlemen who are about to talk front-end apps.
Good afternoon all. I'll be talking about improving the performance of web applications. Let's first talk about the life of a developer. The usual life of a developer, it's like whenever new technology comes in or the new JavaScript framework that comes in, we spend our time learning about that framework. We implement that framework in our day-to-day life or in the project that we are working on, and we try to improve the performance of the application. Come next year, another new technology, XYZ technology or framework comes along. We spend our time studying that framework, and we again implement that and try to make our apps even faster. And this cycle keeps on repeating itself. So as you can see, we just keep on learning about the new technology or the new framework each year. This problem is like a never-ending. So to overcome this problem, there is a new technology or a solution, you can say, that is web component. So what is web component? It is independent of any of the framework. Whether you are working on Angular or React or Vue, it works completely independent of that. The reason for that is it is purely built using HTML and pure JavaScript. So it doesn't depend on any of the framework. You can implement it in any of your application or the existing application. You can convert your Angular product into a web component, and you can start building the application. The best part about web components is it is supported by all the major browsers. As you can see, all the major browsers supports web components, and those who don't support, we can implement that using polyfills. That solves our major problems of selecting a framework before each product or an application that we start working on. We spend most of our time thinking about what is best for this application or what is best for this product. We try to figure out, we do analysis about Angular, React, or Vue. But this web component solves our major problem. We can just start implementing it. So this solves one of the major problems of a developer. But the other question that we have in our mind is about the performance. The performance plays a very important role in any online venture. High-performing sites engage and retain users better than the low-performing sites. Slower the content that loads on the screen, more the number of users keep going away from the application. In this fast-paced world, we want everything to be loaded within the seconds. We don't have time to wait for the content or to use an application. We just need everything fast, no matter what application, whether it's a heavy application or a light. We just need our content to be ready within the seconds. So performance is also about retaining the customers or the users. It improves the user experience to a great level. As the content is loaded on screen faster, users try to engage in our applications and try to stay on the applications for more time rather than looking at just the loading screen. How to measure the performance of your application. So there is an open source tool called Lighthouse. It not only measures your performance, but it gives you analytical report of how to improve your performance of your application. It suggests you the techniques, and the best part is it is open source. I'll be talking about one of the techniques to implement or improve the performance, which is server-side rendering. But before I move to the server-side rendering, let's just see what exactly is a client-side rendering. In a traditional client-side rendering applications, what happens is browser sends a request to the server. We get a pretty HTML and a JavaScript tag where our script file or where our most of the JavaScript code lives. Browser again sends that request and tries to fetch in JavaScript file. Once we get that file, we finally have our content rendered on the screen. So as you can see, there are multiple requests just to load the content on the screen. It just slows down the user experience and it kind of frustrates the user. To overcome this problem, there is a technique called server-side rendering. Server-side rendering has been in picture for a long time. Like it's been existent since the existence of server programming languages like PHP, Python, Ruby, or say Java. But earlier there was a lack of bandwidth, lack of dynamic content available. Now, as we are moving in this fast-paced world, the bandwidth is way faster as compared earlier, or the dynamic content is available on a huge scale. So server-side rendering comes along back in picture. In server-side application, browser sends a request and boom, there it is. Your content is loaded on screen. You don't have to wait for additional round trips, or browser doesn't send any additional round trips to get the content. It just sends one request and you get the content. What it does is it avoids additional round trips. It renders your application faster. It brings along the fast first paint and first contentful paint. And rendering on the server makes it possible to avoid seeing lots of JavaScript in the client, which helps to achieve a fast time to interactive. So as the content is loaded faster, user can start interacting with the website faster. He doesn't have to wait or see the loading screen for even for a second. So here's the performance report of a client-side rendered application. The 48% is the performance. Browser tries to hit multiple requests and fetch the content, and that's why it takes a lot of time. But if you see on a server-side rendered application, the performance shoots up tremendously. It sends just one request and you get your content readily available. And that is how you can improve any application within a seconds. To achieve a server-side, there are multiple technologies available right now. If your product is an Angular, you can build your application using Angular Universal, which is a server-side technology. Or you're working on React, then you can use Next.js. That is another big thing that's coming up. You can easily convert your existing applications into a server-side application. So we had built a small server-side application to fetch the blogs. And if you can see, I will just reload this page and it reloads within seconds. The user experience is so good that you don't even feel like the data has been fetched from the server, or you have to keep looking at the loading screen. It just renders the application within a millisecond. So that's how server-side technologies or server-side rendering improves the performance of any web application and improves the user experience. It keeps the user engaged into your application more than compared to just staring at the loading. So this is one of the techniques that I discussed about improving performance on the web application. Let's just see how we can achieve this on mobile. So Vaibhav is a colleague, he will take over.
Good afternoon everyone. So my name is Vaibhav Zatam and this is my second time on this stage and I'm already loving it. Chinmay has stated about problems of front-end frameworks and how they are all converging into the single platform called web components. So you have a single layer of web component that is reusable across all the frameworks, and that's how we are getting reusability on the web. But the sad truth is we are not only limited to the web. We have numerous of devices that we access on our daily basis. In fact, the recent study shows that we access our mobile devices more than 15% in a year. That's almost around 10 years of our entire lifetime. That's like we are spending 10 years on our mobile devices. Isn't that interesting? But this gets us the opportunity as a product owner or product company or a mobile developer to reach our end users and to provide them a beautiful and interactive experience of a product. But the problem here is same. As we have multiple platforms, we have to build for multiple platforms. And to build for multiple platforms, we have to set up multiple teams. And that comes along with a lot of cost, huge cost. And there are other problems as well. So we have to maintain the consistency between these two platforms or the multiple platforms. And there are lots of other problems that comes along when we start with the actual development. So how do we achieve the true reusability? How do we have a single common interface that works across all these platforms? So there have been multiple efforts to resolve this issue. And I would like to discuss all of them one by one. But before that, I would like to take this opportunity to remind you about the approach that we discussed in the last year summit. The approach is called PWA, that is a progressive web app. So progressive web app is basically an application that is completely offline, installable on user's device, and has access to all the web APIs. The only thing that it lacks is it doesn't have access to the platform native APIs. What I mean by that is, if you want to access the user's contacts or the sensor information of the mobile, you cannot do that with PWAs. But I still feel that it's a viable solution if you want to reach faster to the user's device. Most important thing here to note is that if we have existing website, we can easily convert that that website to a PWA within just 10 minutes of time. I repeat, 10 minutes. The other approach that people were trying out is the hybrid mobile web application development. You just wrap that website in a web view and you have all the access to the APIs, native APIs, through the concept of bridge. A bridge is nothing but a foreign function interface that is exposed from the native side. So this is a native application architecture. The native code is directly communicating with the platform services and the widgets. Other approach that we've been trying out in the last year is the React Native approach. React Native lets us basically create a fully native UI element with just JavaScript and React. So you have your existing web team create the mobile applications for you as well. There's the cost saving. But the problem is, even though this architecture is more performant than WebView, it is still not comparable to the native application performance, but it works. So we have now got the reusability, but we are lacking in the performance. So how do we bridge the gap between performance and reusability? Today, I would like to take this opportunity to introduce you guys to the concept of Flutter. Flutter is basically a open source platform developed by Google, which lets us develop the fully native applications in a faster speed with single code base. There are lots of features that are really interesting, but before that, I would like to take this opportunity to answer this question: why Flutter is so fast as compared to the other approaches? So Flutter basically gets compiled, pre-compiled to the native code, so it doesn't have to go through the bridge every time, as in case of React Native. So the most important feature of Flutter is it has feature called hot reload. So this is a sample application which is created using Flutter, which is running on both the devices, Android and iOS. If you see, it has a smooth animations. I have this code written in the Flutter. So Flutter has a concept of widgets. So everything is widget. Google has already provided all kinds of widgets to us. So we don't have to rewrite them again and again. So I'll just change this. I just saved my changes and it automatically got reloaded on the mobile. It helps developers as well to develop the application very quickly. As it's very fast, we can try out different things, different designs, and try them out easily, very easily. The other thing which is really interesting about Flutter is that it already comes with the different frameworks for Android and for the iOS. So it comes with the material design framework for the Android and it comes with the Cappuccino framework for the iOS. The third and the most interesting fact about Flutter is that as the Flutter's render engine is totally isolated from the core part, it basically allows Flutter to run on any device. So right now Google is only focusing on the mobile part, but the Flutter can run on any device which has got the display. There is already a project called Hummingbird which is still in beta, but we can expect it in the next month. It can release. With that project, we will be able to run the Flutter code on the web as well. That's all about Flutter. I hope you liked it. Thank you.
Accion Lab Innovation Summit 2019.